Right. So complex numbers. Why do you guys think we need something called complex numbers? Is maths already and maths is already complicated and is already complex.
Yes.
Why we need complex numbers for? Well, let me just give a preamble, a backstory. So let me just say you have a number line, right? You have a number line. So we have a number line here. Cool. This is zero, right? As you guys would know, this is all the positive numbers on this side. So that'll be one, two, three, 4. Over here will be -1, -2, -3, -4, etc. So Emma, if I start off at +1 and I make a rotation 180 degrees, no matter which direction, where would I end up at?
-1.
Okay. Straight if I start if I'm at -1, right? And then I
Mm-hmm.
make another revolution 180 degrees, where would I end up at?
You end up back with one.
Right, but what happens in the middle? Yeah. What happens?
Complex numbers.
Yes, complex numbers is happening in the middle, right? So complex numbers adds an additional dimension. So over here, you would call this the real number line, right? Emma, I'm sure you would have been aware with like when you're doing Argand diagrams,
Yeah.
right? So you would say this is the real elements, and then you would have this axis here, which would be for the imaginary part of the number, right? And I would call this axis imaginary z. So, Shweta, I understand that by me having another number system, I could now do a rotation in the middle. Watch. See what I'm talking?
Mm-hmm.
I could do a rotation. So instead of me doing a rotation of 180 degrees, um, let me show you what I mean. So before, to all your knowledge, we could only rotate 180 degrees, but now we could stop at any point we want along that process. You understand what I'm saying?
Yeah.
And if I do that, well, this would be I, this would be 2i, this would be 3i, this would be 4i, right? This would be -I, this would be -2i, this would be -3i. So Shweta, let's just say that I started at 2 and I rotated something like 45 degrees. That looking like, what would that point looking like? What does that point look like?
You mean like to say give a coordinate?
Yeah, give me just a coordinate.
To, well, I point something maybe.
Nah, 2 comma I, right?
Just I, okay.
2 comma I. So if I wanted to express that as a number, I'd call that number 2 plus I. So the real part is 2
Mm-hmm.
and the imaginary part is I. And from your laws, like when you was doing trigonometry all the way in Form 5, and since you know the length here is 2, and you know what this length over here is, and you could figure out the angle for
Mm-hmm.
between the real axis and the quote unquote vector. Check it out.
Yeah.
We could figure out that if we wanted. You'd have to use trig ratios. So cool. That's just a reason for why we need imaginary numbers. So what exactly is an imaginary number? Let me look at square roots. Can we find the square root of a negative number?
No.
No, we can't find the square root of a negative number. And so if you can't find the square root of a negative number, it's just not possible, right? Remember, if I have something like the square root of 25, I'm asking myself, what by what is 25? So 5 by 5 is 25, minus 5 by minus 5 is 25. Is there any same number I can multiply that would give me minus 5? Yeah or no?
No.
No, that just simply don't happen, right? That don't make any sense.
Mm-hmm.
And so if you have the square root of a negative number, that actually forms its own number, right? That forms an imaginary number. So a complex number is made up of a real part and an imaginary part. Just remember that. And the imaginary part is the square root of the negative number. So let me start off with this. So a straight type. If you see square root of -1, that's the same thing as I. Understand?
Right, yes.
Cool. If I had the square root of -5, And so I could write that as the square root of minus 1 by 5.
Mm-hmm.
Think back at surds. This is surds we're dealing with here. Square root of negative 5. Negative 5 is the same thing as 5 by negative 1. Yes or no?
Yeah.
So if I were to split this up, that would be the square root of 5, right? By the square root of negative 1. Yeah or no? Tell me
Mm-hmm.
so far.
Yeah. No, yeah, I understand.
Emma, you understand that? Emma?
Uh, Emma, you are alive.
I'm not sure what's going on with Emma. I see she just like vanish.
Oh, she was okay. I don't know. I don't know if she internet was giving trouble or something.
Send her a message, right? But Trita, if you have the square root of 5 square root of minus 1, that would just be equal to root 5i. Right? Let me know if you understand now.
Mm-hmm.
What if we had the square root of negative 9? What would that be equal to?
Square root of 9 um by minus 1, and you get 3 root minus 1. So it could be 3i?
Yep, 3i. Awesome. So you understand that, right?
Mm-hmm.
Nice. So I would stand for, it belongs to the set of imaginary numbers, right? Set of imaginary numbers.
Oh, Emma said she internet dropped for a second. She internet real bad. Like really
Emma,
bad.
Emma, who's your provider?
Digicel.
Digicel. Um, I can't really say it makes sense. If you say Florida, I'll tell you it makes sense. I don't know why. I'm really not sure why.
In this area, Digicel gives a lot of trouble for some reason. It just depends. It probably is work good in like it used to work good in like P&M areas, but it just doesn't work good here.
Okay. Um, so I is a set of imaginary numbers. A complex number is made up of a real part and an imaginary part. So the form of a complex number is a plus bi, right? And we could call it z, right? So form of a complex number.
Wait, so you don't use the black background anymore?
Nah, it make I know like we had like a spiritual connection on the black background. I know, but like it just ever since I buy a printer, it just makes sense to do some white.
Oh, okay.
Yeah, I know it's greatly missed. Those were great times.
That's how I always do my nose because my eyes, because I was viewing the iPad so much now, it's make my eyes hurt when I always see the white.
Oh, maybe one day I'll go back to the black background, but for now, I kind of standardizing it to be white. I'm not racist or anything, eh? I'm not racist or anything. Alright. Yeah, so form of a yeah, definitely can't post this on YouTube publicly. Right? Form of a complex number. So we could have a complex number, we could call it Z, right? So Z would be equal to A plus BI. Shweta, do you think you could recognize your real part there?
A.
A is the real part, and B is the, well, B,
Complex.
Imaginary.
right. Right, so I would say that this is this is a real part of Z, and this is the imaginary part of Z. Let me know if you're okay with that.
Yeah.
Yeah.
Okay, cool. Right, so I'll give you all some time to copy down the notes. Right. So, do you all remember what the discriminant is? Yeah, no, maybe.
B squared minus 4AC.
B squared minus 4AC. Now, guys, do all quadratic equations have real solutions?
Mm-mm.
And surely I remember the off time I tell all to put something into like calculator, you put something wrong, and then you start to see iron thing pop up.
Yeah.
So that'll happen. Right now you actually have to deal with it. You can't just toss it aside. You have to deal with it now. Right?
Ah.
Yeah. So I'll show you guys what's gonna happen. So as soon as I copy this down, let me know.
Your handwriting's so neat, so
Is it? Or you should see my notes in UE like that is neat. I will show you fast. Check this out. Where is it? Here it is.
wow.
Mm.
Uh, I would
Slay.
I would feel to study my notes if they look that nice.
I go send it to if I do electrical engineering. I go send it.
Hey, see, now people settle their notes, so you could do that.
I thinking about it, you know. Yeah, I would really I was like, I'll
Yeah,
consider that. Hmm.
people like on TikTok and stuff, they just have like links to for people to go and buy their notes and stuff like that. The aesthetic notes.
I will do that. Right now, I see in success in like students, like I think one of my group chat have 20 people. And that never happened before. Like that never happened before. I know it's like
Which
a small number, but like
mhm.
to me it's like big.
What
Yeah.
subject?
That's maths.
Okay, okay. Meh.
Right. So copy that down and we look at the graphical interpretation with the discriminant. Emma, your Wi-Fi can't hold a baby. I don't know if you get it. Shit, you
I,
get it? I told Emma that her Wi-Fi cannot hold a baby.
Does it keep dropping?
Yeah, yeah. That's, that's
So you come up with that.
yeah, come on for that.
Mm.
Right, so guys, as soon as you have that copy down, tell me so I can move on. And let me just do a little sketch of the graph. So this is what the graph would look like. So this is the imaginary part.
Okay, finish.
Now, since it's understood to be the imaginary axis, you actually don't have to put I, right? 6. It's understood to be a component of I. 2. So you all could here what you don't have to put in all of these numbers, but I expect you to at least draw it and put the axes. You need to know the axes. You cannot mix up the imaginary and the real axes. You cannot do that. Why am I putting negative here? 1, 2, 3, 4. Right. Right. Just testing. Shweta, if I were to put a point over here, right? No, that's too easy. If I had a point over here, how would I write that number? If I had a point over there, how would I write that complex number? If I had this.
As the
Yeah.
as the coordinate, it will be 3, comma 2i. But if you had to like write it in the form, it will be 3 plus 2i.
Yeah, so z would be equal to 3 plus 2i. So that would be represented by 3 plus 2i on the Argand diagram. You see this? We call this the Argand diagram, by the way.
Oh, okay, okay.
right? So I'm gonna move on, all right? So we're gonna look at the graphical interpretation. Now, just a recall, I just want you guys to remember something. Recall that the discriminant d, just write d. Recall that d was equal to b squared minus 4ac. Where does that come from, guys? Where does that come from?
The discriminant. Wait,
That is the discriminant. But where does it come from? That's the question.
the quadratic equation.
Right. So just remember that x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, Shweta, why do you think that component is so important?
It tells you whether it's going to be real or not.
Exactly, because if you get a quadratic, right, Shweta, and you would find b squared minus 4ac, look at where it is. It's inside a square root sign. And depending on whether it's positive or negative, you'll get real or imaginary answers. Yeah, because if you get a quadratic and you find the discriminant and you get a negative number, that means you'll have to find the square root of a negative number, which will give you a complex answer. Understand?
Yes.
Cool. So generally speaking, if the discriminant is more than 0, tell me something, right, Shweta? If a number is more than 0, that means it's a positive number. Could I find the square root of a positive number?
Yeah.
Right, I could find the square root of a positive number, and let's just say the number inside was 4, right? What's the square root of 4, guys?
2.
2. So if that's the case, and I would have two solutions where I could either add or minus 2. So then in that case, I would have real and unique solutions. You understand? Because in one answer, you'd add 2, and in the other answer, you'd minus 2. So real and unique solutions.
Okay. Unique is because of different
Right.
in signs.
Right? And you could also say real and distinct. Real and
Right.
distinct. So
Yeah.
that graph would look a little something like this. This is what the diagram would look like if the discriminant is smaller than 0. This is what we are familiar with. Right. Emma, can you tell me what would happen if the discriminant was exactly 0?
I know that's when the roots are equal.
Roots are equal. Yes. That's when the roots are equal. And Shweta, let's look at why. Shweta, if we replace b squared minus 4ac for 0, then you would either add or minus 0. Tell me, Shweta, does adding or minusing 0 make a difference with the answer? Shweta?
No.
No, if I add or minus 0, it won't affect the root at all. So if your discriminant is equal to 0, it means that you only have one solution for x. And if you were to factorize it, you would get something like, let me show you where you get. You might get something like x minus 2 by x minus 2.
Yeah.
In this case, right, x would be equal to 2 and x would be equal to 2, yeah?
Yeah.
How much solutions does it have over there?
1.
You might be tempted to say 2, but it's the same solution. X is just equal to 2. And let me...
It'll just be a point.
Yes. It will just be a point. It will be tangential to 2 on the x-axis. So, x by x is x squared. That'll be maximum or minimum. Tell me, Emma. X squared. Maximum or minimum?
Minimum.
So it would look like that, right? Wait,
Yeah.
Shweta, tell me if you're confused.
What do you mean by x squared?
If you were to expand this, right?
Okay.
So if I wanted to sketch that graph would look like this because it has one root, right? That's x is equal to 2. and the shape of the graph would be a maximum turning point.
Right, okay. Now just to know where you get the where you say x squared from. Okay. But yeah, I understand.
All right. Wait, my baby cousin. Wait, your teeth just fall out?
Yeah.
Let me see.
Mm.
You see, she go and get rich because his teeth fall out.
Oh my
Wait, let me go. Ranch, Ranch. I want to take a picture of this.
God.
Smile, smile. Ranch, Ranch. Let me see that. You can close any more. All right, let me continue.
Oh.
Go wrap up your tooth in a paper towel.
How Bella's ready to fairy.
Yes, go do that. All right. Yeah. So everybody understand what's happening so far, right?
Mm-hmm.
Yeah. Emma, you sure it would look like this? Emma, you sure it would look like this? Because if it's x squared, right? It's positive, it's smiling. You sure it would
Yeah.
look like that?
No.
The odd maths. We gotta remember the odd maths. Emma, like, I gotta understand, I hold all it to a certain standard, and I would trust what all they're saying. So, Emma, you just not tell me you'll be a maximum, you know.
No, I said a minimum.
You said a minimum?
Yeah, I
She
said
said, yeah, she said minimum.
Oh,
She
I
said
hear,
minimum.
I don't know why I hear maximum.
So
All
it's
right.
the end of the week.
I
The week.
almost said maximum, but I said minimum.
All right. So, Shweta, you understand what's going to happen if the discriminant is zero. And if you have trust issues, we could expand this out and find the discriminant fit. But you will see that is zero, right? So,
Mm-hmm.
Shweta, if we expand that out, you're going to get x squared minus 2x minus 2x minus 2 and minus 2 is plus 4. If you realize A is 1, B would be minus 2 is minus 4, and C would be 4. Understand?
Mm-hmm.
If you find B squared minus 4A is C, B squared minus 4A is C, B is minus 4. So I'm going to say minus 4 squared, right? Minus 4, A is 1, and C is 4. Straighter, minus 4 squared is 16, minus 4 by 1 is minus 4, minus 4 by 4 is minus 16. What are you going to get?
0.
Right, so anytime you have repeated linear roots or repeated linear factors, it means that you're only going to have one solution. And before you factorize, you could just find the discriminant, right? The discriminant will tell you if it's going to be real and distinct, real and equal, or imaginary. Everybody on the same page?
Yeah.
Great.
Wait.
All right,
When
so
it's less, if it's less than 0, oh, I know it says not real and not distinct. That means imaginary.
yes, it means imaginary. If it's less than 0, it means that the roots, it would exist in conjugate pairs. That's what you're learn, right?
Yeah.
Yeah. Mm-hmm. Shweta, you'll understand what we meant at just now. Right? So this is when the discriminant is actually equal to 0. Right? So over here, it's going to be real.
Isn't it supposed to be on the 2? Oh no, that was just for the example.
Yeah, that's just a general example. Real and equal. What's it? Real and distinct, right? Distinct. This would be real and equal. And Shweta, when the discriminant is negative, something crazy happens, right? Do you know how the graph for that would look like? Tell me, Shweta.
Does this look like the Argand diagram?
You say now it would look
Or
like
not?
a Venn diagram?
You say something crazy, so I'm asking if it'll look like the Argand diagram. Something like that.
If you, not quite. If you are plotting it on the y and x axes, this is what's going to happen. So you understand that if the discriminant is more than 0 or is 0, you're going to get real solutions, right? So in other words, it's going to cut the x-axis. Why? Because the x-axis contains the real elements. And this is just a regular plane, right? Both of these axes are real. So straight up, if you end up with the square root of a negative number, which is imaginary, does it have anywhere you could get the x value for that? Tell me straight up. In this diagram, is there anything to represent the imaginary number?
Mhm.
No, because this is just a regular real axis, a real x and a real y. So if the discriminant is actually negative, it's not going to have a real root straight up. So it's just going to be somewhere above the x-axis.
Okay.
Mhm. And this is going to happen when b squared minus 4ac is less than 0. So you would say that they are imaginary or complex roots. And Emma, like you said, these roots would exist in conjugate pairs, so they would be distinct. Right, so you all could copy that down quickly.
I just going a little off topic. What kind of page you using right now? Because I noticed the box is smaller.
It's smaller. I'm using the standard squared paper on A4. It should come with all good notes. Like, yeah, I think even the free version.
I'm using GoodNote Standard. I'm not using A4.
Oh, and they don't have the option?
Yeah, I have the option. I'm gonna change it now.
Okay, cool.
Oh
Hey,
yeah.
sir, I got iPad.
You get an iPad?
Yeah.
You're one of the iPad kids now.
Yeah.
You shouldn't be saying
Yeah.
that so happy. Have you seen the statistics for iPad kids?
Oh gosh, so it's for making aesthetic notes.
Mhm. I tell you, like my cousin's an iPad kid and he'd just be saying the most crazy stuff.
Oof.
Like he'd be skibbity, skibbity, yes, yes, all kind of crazy thing.
That's
Skibbity
just because
toilet.
he on
Skibbity
TikTok.
skibbity toilet.
Yeah, he be talking about some weird stuff. Like he'll be like Sigma, Sigma boy, all kind of thing. You gotta keep
Yeah. Yeah, that's me and Emma, but that had nothing to do with iPad. I just TikTok.
that's just the TikTok brain rot.
Yes,
Tralala,
actually.
tralala. Bombard.
Bombardilo,
Trippy
crocodilo.
droppy.
Yeah.
Tung 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 tung
Sahur.
sahur.
It's so addictive. The brain rot so
I know.
right.
Oh,
Oh,
So
that's my iPad. Well, since I get the other iPad, I was like, I'll give it to my old one.
oh, so you give charity then.
yeah,
Well,
basically.
she paid for it.
What? She paid.
I I didn't want you to just give me it for free. That's all. Mm-mm. No.
Okay. I say I'm gonna give it for free.
She was
I
giving it for
was.
free.
How much did you pay her if you don't mind me asking?
500.
Oh
She
well,
said she said that amount. Just oh, that is my mommy had a field trip. So she said just give she 500 and she will use that when we going on a little shopping spree during the field trip.
oh.
Hmm.
So you had a field trip, right? Your mom had a field trip
Yeah, yeah. With her students.
with her students. And how did $500 come into play with that? Tell me again.
Okay, so I invite Emma on the field trip with us. So we went to the zoo. Then we was going to the mall. I don't remember the name, which am I remember the name anymore?
As long circular mall.
I was gonna make
Yeah.
I was gonna make an out of pocket joke, eh? It's gonna,
Oh.
I was gonna like you give Emma money to save some of her family.
To save some of her family.
Yeah, because they is a real dark joke. It's like her family is behind cages in the zoo, come like they're slaves,
Oh,
and so you give her money to buy them back.
What?
oh, oh.
Yeah, that's a dark joke, really, really dark.
Random. So.
Yeah. I remember like in real dark humor though, like I used to make some dark.
Yeah. Yeah, we still do, but we just didn't get that one. But don't worry, so we still laugh regardless.
So you're saying that the money you gave the money that you gave Emma, it just she just used it on that day.
Yeah.
I see. Well, it worked out.
Yeah.
So
You don't have to beg she to take it.
yeah, I would not accept that money from my friend. You probably make Emma feel bad.
I will not
Alright,
feel bad to just take it.
it's okay. It's fine.
So as soon as you have this copy down, tell me I want to move on to why when you have imaginary roots, they would exist as conjugate pairs. Shweta,
Yeah.
Shweta, do you know why? Do you know what is conjugate? You should remember from SUDS.
A con is like where you switch the sign?
Yeah.
Yeah.
Yeah, like imagine you had 2 minus 5x. The conjugate for that would be 2 plus 5x.
Right.
You just push any sign in the middle, right?
Mm-hmm.
I think you could already see why. If you look at the formula for the quadratic equation, notice there's a plus or minus. See that?
Yes.
So the solution would always be an even split. We'd have a positive part and a negative part. Right, but I'll do an example. So as soon as you have this copy down, tell me, I want to move on to an example.
1 minute.
I'm done.
Okay, cool. I'll remember alpha and beta.
Yeah.
Yeah.
Okay, good. You need to know that. You'll need to
For
know.
real?
Yeah, for real. You see, like a lot of this stuff you learn in AdMaths is the foundation for this. If you
Mm-hmm.
wasn't good in
Yeah.
AdMaths, you'll be
We
screwed.
have it have trigs and thing in this, so I have to go for my trigs too.
Yeah, sure. So I remember how I drew the Argand diagram and it formed a right
Okay.
angle triangle. Remember?
Okay. Yes.
Yeah, so you'd have to find the angle between that line and the x-axis. That's what you're talking about, Shweta. I mean, Emma, that's what you're talking about. When you had to find theta for the Argand diagram.
Yeah. It has proofs and stuff to do too, and you just need to know some of the
What the
identities.
hell?
That's
It's
what we're doing right now. And we using
the Morse theorem.
yeah.
Right.
Okay,
I
then hear
just
that
I
name
think of
before.
it as De Moivre because that's how you spell it.
No, it is kind of sound like the Moiva, to be honest.
Okay, I finished with the answer.
All right, so we're gonna look at a quick example. So let's just say we had a quadratic and it was in the form, well, it was x squared. We had a quadratic x squared plus x plus 1 equal to 0. Guys, tell me fast, what is a, b, and c? What would a, b, and c be? A is equal to what?
A is 1, B is 1, C is 1.
Cool. Straight, so if we plug that into the quadratic equation, I trust we're at a level now, we can do this math fast. So straight up, tell me fast. So negative b, tell me it one time. That'll be negative 1.
Wait, we're talking about.
So we're going to use the quadratic equation to solve x
Mm-hmm.
squared plus x plus 1 is equal to 0. So I
Oh,
could,
how to call it out.
yeah. So,
Oh, okay.
so don't call out the formula, right? Apply the formula one time. So negative 1
Mm,
plus or minus,
yeah. -1 plus or minus square root 1 squared minus 4 1 by 1 all divided by 2.
perfect, right? Negative 1. So that would be 1 squared, which is 1. 1 minus 4 by 1 by 1 is just minus 4 all over 2. Right. So x would be equal to negative 1 plus or minus the square root of negative 3 over 2. Can we find the square root of negative 3?
No.
No, matter of fact, it's actually its own number, right? Imaginary number. Shweta, remember what we did at the start of class? I told you that we could write the square root of negative 3 as the square root of -1 by 3, remember? Right? So here what? We're going to split it up into its parts one time. So straighter, we could consider the positive part. So if we consider the positive part, that's going to be -1 plus, and let's do it one time. So that's going to be -1 by 3 all over 2. Cool. Right? So that's one of the solutions. You could call that x1. And the negative part, that's going to be x2. x2 would be equal to -1 minus the square root, the same thing essentially, all over 2. So straighter, if this is the case, right, x1 will be equal to what? That'll be -1 plus, so this
3i over 2.
now root 3 I,
root 3i over 2.
right? And if I were to separate the fractions, you'd end up with -1 over 2 plus root 3 over 2i, yeah. And you'd end up with -1 over 2 minus root 3i all over 2. What do you notice, Rita?
It's in the complex number form.
Right. So it's in the form a plus bi, and?
Yeah.
Yeah.
Now, but notice something, Shweta. What's the only difference between this and this?
The positive and negative in the
Right.
middle.
So we're going to take note of that. Note x1 and x2 are both complex roots. And if you pay attention to the sign in the middle, you'll see that the only difference is the sign is the opposite. So we'd call it the conjugate. Right? So x1 and x2 are both complex roots that are the conjugates of each other. That's right. So Shweta, you understand what I'm saying? The only difference is just the sign in the middle. So anytime you are dealing with a quadratic equation and the discriminant is less than 0, automatically it's going to have complex roots. You hear what I'm saying, Shweta?
Yep.
Its solution is not going to be real, right? But what we do know about the solution is that it will always exist as a conjugate pair. So Shweta, if I told you that the root for a quadratic equation was -1 plus 2i, automatically you should know that this quadratic is not going to be real. You're going to get imaginary solutions because look, the solution is literally a complex number. You see that? x1. So since we know that all the complex solutions is going to exist as a conjugate pair, if x1 is -1 plus 2i, what do you think x2 would be?
-1, -2i.
Perfect. Yeah. So if the discriminant is less than 0, you're going to have complex roots. And if you have complex roots, they are always going to exist as conjugate pairs. Always. So Shweta, in the questions, they might give you one root and they would tell you, using that, find the equation, find the quadratic equation. I'll show you how to do that. Right? But you understand what I'm saying?
Yes.
Cool. Emma, I feel like you understand that a long time.
Yeah.
Nice.
Emma's our boss.
Well, you see, she do it already, yeah? She have advantage. You seen it for the first time.
So like when we reach differentiation, he'll have to focus on me. Well, integration.
Trust me, differentiation harder than integration at this level. When we start looking at a second order non-homogeneous, oh God, you're gonna hear that. That's a 20 mark question by itself.
What?
Yeah. Think I'm joking? Seriously, that's what my question. Right. Cool. Once you have this down, let me know. I'll I'll give you all a question.
Yeah, I have a question.
Sure.
So just like how you're saying, they could just give you one route and you just have to write the next route and you solve the question, right? So, like with some questions, sometimes they just want you to put a little explanation. In that case, like to show how you come up with this next route, you could put that little note that you write there, the x1 and x2 are both complex roots and they conjugate of each other.
Yeah. And if you want to be extra bougie, you could make reference to the quadratic equation because Shweta, and by definition, the quadratic equation says that the solution is just going to be plus or minus whatever is being square rooted. Doesn't it say that?
Mm-hmm. Mm-hmm.
So you could code the quadratic equation, right? The quadratic equation tells you that it's plus or minus of the discriminant. That's what it says. And so whatever answer you get, you're gonna have the only difference is gonna be one is positive and one is negative, right? And so maybe I could write this a little better. So x1 and x2 are both complex roots, right? Are both complex roots. I'll write a more standard statement. But the reason why they exist as conjugate pairs is because the nature of the quadratic equation, the plus or minus there,
Mm-hmm.
right? So x1 and x2 are both complex roots, right? Anytime the discriminant is the roots will exist as conjugate pairs. Just please remember that.
Can you zoom out a little bit, sir?
Sure. Shweta, are you still obsessed with K-pop?
Yes.
I was curious. Because I know some people that outgrow it.
Nah, that's part of me.
Okay.
I didn't outgrow it. K-pop just went downhill.
It did. No, it
My
did.
gosh.
It did. Like I remember when like BTS was like peak.
Yeah.
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 Yeah, I also like how like the bands and stuff, they more lean like towards the more tempo kind of music and not the happy kind of music.
Tempo.
Oh gosh, how to say it? I don't know how to describe it. Like more, what, what appropriate word to use?
Appropriate. Whoa, whoa,
Like
whoa, whoa, whoa.
like upbeat.
No, like okay. So in the past, right? You know how the music used to be upbeat, same upbeat, but like more happy.
Mm.
Like, yeah. Now it more leaning. Oh, the music more leaning towards like two-strap kind of music, kind of things.
Like like lustful. Lustful.
Yes.
Ah. But like I see like a lot of girls go crazy. Like I would just be like I have a lot of like girl students and like a lot of them just follow me on TikTok and I'll be seeing reposts and I'll be like, oh my God, I
Oh,
shouldn't be seeing this. I should not be seeing this. Like I know exactly what you're talking about.
yes.
It could be like
Yeah.
this K-pop man and
Yes.
yeah and it, boy oh boy. Anyways, as soon as I finish with that, let me know. I'm gonna give a question.
What?
I have a question. You making your notes aesthetic or you just like jotting down?
I just writing it down like how he have it here.
Okay.
Yeah, this is it. I hardly have the time to make it extremely aesthetic. I mean,
No, like I mean like okay, see like how you give me time to write there. I'm trying to remember for maths and advanced days if you used to do that or you just used to like write it and then we used to jump into a question.
yeah, and I realize like I cannot change that because with the Form 4s and the Form 5s and the new students are having, I realize
Mm-hmm.
that when I do that, they don't really get the time to copy down the notes and everybody just make the effort to copy down the notes after class.
And
Like, but
you
like
wanna copy notes after or you wanna like take the time to copy now?
I wouldn't do it after.
am I serious? So,
I I I don't really mind reading your notes.
but you wouldn't like
It's,
copy it down.
I might maybe while I'm in school I would copy it down.
Okay, well, I just go and do what I used to do with all right?
Yeah.
Right? So let me look at a question now. Right? So question. Now, before I move on, right, I have something that I explicitly need to know. So Shweta,
Mm-hmm.
you remember how I told you that the roots will exist in conjugate pairs?
Mm-hmm.
That's only the case when the coefficients for the quadratic is real. If it's not real, then that's not the case. So I'll make a little note about that. Right? So given any quadratic, it's seriously not telling me spelling quadratic wrong. Now that's the correct spelling. Right? Given any quadratic equation, you're gonna notice that they love to use z a lot. Right? So when we're talking about complex numbers and things, they like to use z.
Yeah.
They fed up at X and Y.
Yes.
We
And
we
another reason is because you can think of it as the complex number system has another dimension. So XYZ. Think of it like that.
Mm.
Right? Right? So once, right? So where A, B, and C are elements of the real number system, only then will the roots exist as conjugate pairs. Right?
your iPad time like 2 hours late.
No, no, it's all I can't believe I never realized that it is always show 941. It's never changed. It's never changed. It never
What?
changes.
My my one a hour late.
No, but you see, the thing is, right, as soon as I disconnect it from my laptop, it will show its regular time. But once it's connected to my laptop, it shows 9:41. I'm not sure why,
Mm.
right?
So going a little off topic was what size can you use to write?
I'm using, wait, 0.4 millimeters.
0.4?
Yeah, on A4
Oh,
paper. A real thick, I know.
No, I was watching and I was like, why am I looking so because I remember telling me to use 0.25.
I used to use 0.25, but it depends on what paper I'm writing on, right?
mm.
So let's look at a question now, right? Let's look at a question. Now I want to start off, or they want me to throw it into the ocean or like go with an easy example first.
Um,
Easy example and then ocean.
Okay,
yeah.
all right. Given the real and distinct roots, x is equal to, okay, so I've given already the roots, right? So x is equal to 1, right? and x is equal to 2, find the equation. So this is just odd maths at this point, right? This is just odd maths. This is literally just odd maths. So Shweta, if I have the two roots, x is equal to 1 and x is equal to 2, I could write x is equal to 1 as what? If I wanted to write it as its factor. Right now, that's the solution. If I wanted to write does its factor, how would I do that?
Open brackets x minus 1.
Right. Right, so x is equal to 1 is the same thing as x minus 1 is equal to 0. Remember, when we factorize a quadratic, it first needs to be equal to 0, right? So I'm saying x minus 1 is equal to 0. Cool. And then I'm going to say x is equal to 2. So x minus 2 will be equal to 0. Cool. So this would be x minus 1, right, by x minus 2. And Shweta, and we're saying that x minus 1 is 0 and x minus 2 is equal to 0. And we're saying that
Yeah.
0 minus 0 is 0. Cool. Then I'm going to expand this. X by x is x squared. X by minus 2 is minus 2x. Minus 1 by x is minus 1x. Minus 1 by minus 2 is plus 2. And that'll be equal to 0. So did I do anything that was crazy?
No.
Nah, this was easy, right?
Yeah.
Right, cool. Given, right there.
This is the D portion one.
Yeah, this is the D portion. All right. So given the quadratic equation in the form
AC squared plus BZ squared?
yeah, wait. What the hell? Yeah, AZ squared plus BZ plus C, right? What the hell? Right? And one of the roots, Z1 is 1 plus 5i. Find the equation. Find the initial equation. Initial. Cool. So, Shweta, do you think you'd know how to solve this question? Yes or no? It's very similar to the first question we did.
Yeah.
Okay, so we'll go through it together, right? So Shweta, I'm telling you that we have a quadratic equation in that form, and the elements for A, B, and C are real. If that's the case, then we know that the roots would exist in conjugate pairs, right? So they're giving us Z1, which is the first root. Z1 is equal to 1 plus 5i. And if that's the case, and we know the form it's in, we could figure out what Z2 would be. What would Z2 be? The second root.
1 minus 5i.
Right. You could now you could call it Z1 and Z2, but essentially they're just Z, right? So
Okay.
it would be Z is equal to 1 plus 5i, and this would just be Z is equal to 1 minus 5i. So Shweta, isn't it essentially the same thing as this? They give they give you the roots, right? In this case, the roots were real. You see in that x is equal to 1 and x is equal to 2. Yeah?
Yeah.
In this case, the root exists as a complex number. Yeah?
Yeah.
Cool. So we're going to follow the exact same process. Now, Shweta, tell me if I'm losing you, right? So what I'm going to do is I'm going to take the 1 plus 5i and move across that to the left-hand side. So I'll end up with z minus 1 minus 5i is equal to 0. Do you think you understand why I'm going to do that?
Yes.
Yeah? All
Mhm.
right. And over here, I'm going to end up with z, right? Z minus 1 plus 5i is equal to 0.
Oh,
Yeah or no?
Mhm.
yeah.
So, Shweta, you understand that I essentially did what was done over here, right?
Yep.
Right? Because in this case, it had a real root, but in this case, it's a complex number. So it's the same process. So, Shweta, if I want to find the equation, all I would do now, I would write what? What do you think is my next step?
You're gonna put them in, well, to the and then you're gonna put them in brackets and multiply it out, so you get a equation.
Right. Now, can you recognize that this will be a very long process?
Yes.
Yes, this is a very long.
Hmm.
So what we could actually use to expedite this process, we could actually use common products.
You're gonna use what?
We could use sum of the roots and product of the roots.
Okay.
But wait, we're going to do it like this first, right? So let's try to expand this and see how it goes. So Shweta, I'm testing your ADMAS skills here. So we're going to take the first term in the first bracket and we're going to apply that to all the terms in the second bracket. Yeah?
Mm-hmm.
And you're just essentially going to do that for minus 1 and minus 5. So what is z by z?
Z squared
Right? Z squared. What is z by minus 1?
minus C.
What is z by plus 5i?
5zi? Or IZ? 5IZ?
Right?
It
Then
matter?
it don't matter. Remember, multiplication is commutative. But typically, you'd put I last
Last. Okay. I'm
because
just talking about
plus
like for
bi,
form now.
plus bi, plus bi, I
Okay, cool.
last, typically. Then we're going to multiply minus 1 by everything. That's going to be minus 1z, which is just minus z.
Z.
Minus 1 by minus 1 is plus 1,
1.
minus 1. All right. Then we're going to end up
Mhm.
with minus 5z
5.
plus 5i, right? And this is the tricky part, Emma. I mean, Shweta, Emma, I presume you know how to multiply complex numbers, right? But Shweta, check this out. The last thing is going to be minus 5i, right? Minus 5i by positive 5i. You seeing that?
Mm-hmm.
Okay. So let me show you how we're going to work that out. So that's going to be plus minus 5i, right? By 5i. Yeah?
Mm-hmm.
Now, Shweta, my baby cousin, give me a second. He making a lot of noise in the background and it's distracting. Uh, Riansh,
Yeah.
I teach in our class, okay? Don't make any noise. All right. Yeah, give him a goof up there.
Oh, it's okay. We wasn't here though.
Okay, bye here and then and then
Okay,
and
okay.
I need to right. So Shweta, you understand that I said I was equal to the square root of minus 1, yeah?
Mm-hmm.
So if I were to square both sides to get I squared, what's gonna happen with our square roots? If I square a square root, what's gonna happen?
It's gonna poof.
Poof, right? So I squared, in other words, is equal to,
Minus 1.
right, just keep that in mind, okay? I squared is
Mm-hmm.
equal to negative 1. Let's look to simplify here. So we just have 1z squared, okay? Look for terms with minus z. Look for minus z terms. So we have minus
It
over here,
just had to.
right? So that's going to be minus 2z. Let's look for I. Let's look for zi terms now. Notice that these zi terms are going to cancel off. You'll see what I'm talking about. Plus
Yes.
5zi and minus 5zi is going to cancel off, right? Then we have 1 minus 5i, we have 5i, and we have minus 5i by 5i. Now, Shweta, let's work this out fast, right? I just now told you that I by I is what? What's I by I? I squared is what?
-1.
So minus 5 by 5 is going to be minus 25, yeah? And I by I is I squared, be minus 1.
Right.
What's minus 25 or minus 1?
It'll be just 3.5.
Right. You sure you understand everything I'm doing so far?
Yep.
Cool. So the next thing, let's look for any items, and you'll notice that the items cancel off as well, right? Because straight away, watch, we have minus 5i over here, and we have plus 5i over here. See that? That's going to poof as well. And now we are looking at the real numbers. So I'm seeing plus 1, and I'm seeing plus 25. You seeing that? What is 1 plus 25?
And 6.
Unfortunately, it wasn't 9 and 10. It wasn't 9 and
9, 9 and 10.
Yeah, 9 and 10 is 21. Remember the meme?
Yeah.
For real?
Yeah.
That was a meme?
It's like
Emma,
21.
Shweta is really uncultured, I would say. Very uncultured. I can't believe this. This is crazy.
You're gonna send her a video after class.
Yeah, we're gonna have to do that. Right? So, do you all understand this?
Yes.
Okay.
Yeah.
And Shweta, if you wanted to verify if you're correct, let me show you what we could do, right? Check this, eh? Bam. Look what I have here.
Yeah.
I'm a calculator, right? So, I'm going to solve the equation, right? I'm going to put it in. So coefficient for quote unquote x. In this case is z, right? But it's the same thing. We're just replacing x with z. So the coefficient there is 1. Then we have, wait, no, that was a mistake. Yeah, so 1x squared, right? Minus 2 plus 26. Press equal. Straight up. This is the same thing we started with,
Yes.
right? Bam. You see? Everything makes sense.
Yes.
So that's the long way. That's the long process. Right? So soak it in, because I'm going to show you another way to do it. Because Shweta, I'm sure you don't want to expand that every single time. It probably
No, but I know you have a trick. I know you have a trick for that.
right. We have a trick for that. Right? So soak it in. Right?
It has been soaked, but just in a second, I'm gonna take one of my vitamins.
Okay, no problem. Yeah.
I just had to take it after a certain period I eat.
You see, your mouth once and you had to take vitamins.
Is Mentat, the Himalaya Mentat.
I don't know about that.
I think that
It's
is
just
placebo.
it's to help like with like your memory focusing and stuff like that. But you can't really eat it on like a full stomach. So I eat like an hour ago. So like my food kind of digest enough, so I'm gonna take it.
Okay, okay, all right. So in the meantime, Emma, I want to go through the concept of the summon products, right?
Yeah.
Okay, cool. Right. Did you do the proof in school?
I probably did, but I think that was last term.
Okay. No, baby cousin, realm making noise. So, Emma, I want you to consider a quadratic equation, right? Ax squared.
Wait, is that when you substitute it and you substitute like the whole complex number into x?
Into x. Are you talking about? No, I feel like we're talking about something else. You'll clarify. Are you talking about summon product of roots?
No, I don't think I did it. I don't remember doing that with Miss.
Okay, well, you will see it here. So imagine you have a quadratic equation, right? Ax squared plus bx plus c, and we would have discussed that a, b, and c had to be real, right?
Yeah.
Right. And let me just say that the roots are z1 and z2, right? So z1 and z2, remember Emma, you might probably be saying, well, how am I saying that the roots are z1 and z2 and the variable I'm using in the equation is x?
Yeah.
I want you to understand that z actually stands for a complex number. So that could be in the form a plus bi.
Yeah.
So don't get confused by that. Z1 and Z2 is just there to reference the complex number form. Remember we would say Z is equal to A plus BI or Z is equal to A minus BI. Z is
Yeah.
used to represent a complex number. So tell me if I'm losing here, right? So I have AX squared plus BX plus C, and this would be equivalent to X minus Z1 by X, right? So X minus Z1 and X minus Z2. You're probably saying, by what? Emma, if you solve a quadratic equation and you get the roots, and if I'm saying the roots are Z1 and Z2, wouldn't
Oh,
X be equal to Z1 and X would be equal to Z2?
yeah, I understand.
And then I would say X minus Z1 is equal to 0. And then I would say I would say X minus Z2 is equal to 0. So I think it all coming back to you now. Remember at the start, I said Z just represents a complex number. So
Yeah.
this could be X minus 1 plus 2i for some reason. And this could be X, that would just be, that'd be minus 1 minus 2i, something like that. So you understand what I'm saying?
Yeah.
Cool.
So at the end, you'll bring it back.
Yes. Shweta, you there?
Yeah.
Shweta, I hope I didn't lose you, right? I'm to go it over.
Yeah, this
Um,
is
okay, so is it that you're separating the x's from the z's or something?
Nah, not
The
quite.
equal, okay, I got.
So, Shweta, if you have a quadratic equation, right?
Uh-huh.
And normally you would have the roots like as x is equal to 1 or x is equal to 2. Yeah?
Yeah,
As if it's real, right? You understand?
right.
But if it's not real, wouldn't it look like this? So it would be like a plus bi
Mm-hmm.
because it would be complex, right? Let's just let me check back this. Watch. When we solved the quadratic x squared plus x plus 1, look at these solutions. Wasn't it in the form a plus bi?
Mm-hmm.
It was, right? Say with me so far on that.
Yeah.
So if you have Ranch, you can't play the tablets in the room, okay? Because I teach in a class. I feel like a villain, but
If you like.
a villain. But I teach in a class.
You do have an next room or something, Phil?
Well, right now, he home alone with me.
Oh,
Yeah, so he was
okay.
money to play with. And I teach in a class. So all right. So this wouldn't happen all the time. This just that my aunt and my uncle not home right now. So
Yeah,
there's
yeah.
there to supervise him. All right. So, Shweta, do you understand what I'm saying? Normally, for a quadratic equation with real roots, it would be x is equal to 1 or x is equal to 2. But in this case, I'm saying that it'll have complex roots. So, the roots would be in a complex form a plus bi. Yeah?
Right, yeah.
Cool. Remember I told you that I could write a complex number in the form z is equal to a plus bi?
yeah.
So, Shweta, all I'm saying is a plus bi could be written as z. For now, take the
Right.
as it is. So Shweta, instead of writing something like a plus bi, I'm just writing x is equal to z1. instead of writing x is equal to a minus bi, I'm writing x
Uh-huh.
is z2.
Okay.
Just like soaking, right?
Yeah.
I just gonna tie in all the concepts. So remember at the start, we said that imaginary roots would exist as conjugate pairs, yeah?
Yeah.
And if it have imaginary or complex roots, it would be in the form a plus bi. Well, a plus or minus bi. You understand, Shweta?
Mm-hmm.
And I could write a complex number in the form z is equal to a plus bi. So what I'm saying is, if you have a quadratic equation and its roots are complex, then one of the roots is going to be a plus bi, and the other root is going to be a minus bi. Yeah?
Yeah.
But instead of writing it like that, I'm going to write it as z1 and I'm going to write it as z2.
Don't a tablet start on my iPad.
So after you equate the x and z, what's happened after?
Yeah, back.
Oh, okay.
Yeah. Am I
just
want to go ahead and explain it to her? But wait, before we move on, Shweta, you understand why I'm saying why I could say x
Yes.
minus z1 and x minus z2? Yeah?
Yes.
Okay. Well, I'm glad to hear that, right? So, Emma, you want to explain it to her or Shweta, or you want me to just continue?
Well, all you're doing is expanding it, and then you're going to equate it. Well, you're going to equate it back to ax squared plus bx plus c. And then when you equate it and you like have it in your order, you could bring back in what the original complex number was.
So,
So if
Shweta,
it was
so excellent job, Emma. Yeah, tell her.
no, I just say if it's z1, if z1 was equal to 1 plus 2i, you would
Mm-hmm.
bring back you would instead of keeping it as z1, you would put 1 plus 2i back into it.
Oh, you're substituting it back.
Yeah, instead of working with it throughout the whole thing, you just
Right.
put it in at the end.
Okay.
So, Shweta, check this out, right? Like Emma said, so if I'm calling the roots z1 and z2, I'll end up with the factors x minus z1 and x minus z2. If I were to expand that out, look at what happens. Notice I have an x over here and I have an x over here. Seeing that?
Mm-hmm.
Right? Because watch, x by minus z2 is minus x z2, minus z1 by x is minus x z1. And I could factor out the negative x.
Yeah.
Yeah.
I could factor out the negative x. If I do that, I'll end up with z2 plus z1. Tell me if you're with me, Shweta.
Yes.
Okay, cool. Right. So Shweta, essentially what I'm saying, right? I'm saying that you remember when we was doing odd maths, I told you guys, I would have seen this equation, right? I would have said that x squared minus the sum of roots. Do you remember this?
Yeah.
Yeah. Plus the product of the root.
It's like gonna blow your mind, right? But like, I want you to look at this. If I'm saying that z1 and z2 are the roots, isn't it in the exact form as this?
Oh, shit.
Wow, language. What is it?
Sorry.
That's what. But you see what happened in there, right?
Yeah.
So in other words, if I want to write, Shweta, if I want to get back the original equation, all I need to do
Mm-hmm.
is add the roots and find the product of the roots and put it into this form. And that would give me ax squared plus bx plus c. Understand?
Yeah, I understand, but I need to sit with that question.
Okay, but we're not finished yet, We're not finished yet.
Oh,
Let's
okay.
continue. So the next thing we're going to do is we're going to divide both sides by a.
Oh.
So you're gonna see something very cool. So Shweta, you remember in odd maths, I would have told you that if you want to find alpha plus beta, it would have just been minus B over A.
Mm-hmm.
And if you wanted to find alpha beta, it was just C over A.
Yeah.
I've shown you the actual proof in class today, right? I've shown you how they come to that. Right? In this case, it would be Z1 plus Z2 is equal to minus B over A.
Yeah.
And it would be Z1 by Z2 is equal to C over A. But I just want to show you how they come to that point. So, Shweta, if we divide both sides by A, so Shweta, if we divide both sides by A, AX squared over A is just X squared. We're going to end up with B over E X
You
plus
just blow my mind.
You learned that in school though,
No, I probably wasn't paying attention.
right?
No, she didn't teach us this.
Like she did not all.
No. Well, she didn't connect it to the roots like how you did it. She did the part above, but she didn't explain how they came about with it.
Ah,
but she used the same minus B on A and C on A.
No.
Oh,
she, okay. Well, that's interesting. I think it's good to know how they come up with it. I mean, like, I was always sure this, eh? I was always sure how and why. How did they get to the point?
She doesn't always show us everything. She shows us more what she thinks we would be comfortable using.
I see.
Yeah.
So everybody understand how I reach up to this point? Yeah or no?
yep.
Yeah.
I must say I'm really excited. Um, let me explain why I needed to divide by A, right? And they would have like when you was doing alpha and beta, someone product roots. And it had some times where they wanted you to like, okay, let me just say you'd I guess something like into probably would I guess something like 7 over 2x plus a half or something. You know what I'm talking about?
Mm-hmm.
And you'd have had to multiply by 2 throughout.
Yeah, yeah.
So you divide them by A because it's the reverse. It's the reverse. Right? If
You want the two equations to like be equal. in a
yeah,
sense.
exactly. I want the two equations to be equal. So notice that this by dividing throughout by A, it's now extremely close to this. You see that?
Yeah.
But so but you're not putting the A, you're only dividing by A on the left-hand side.
Yes, because I want to put the left-hand side in the form of the right-hand side.
Oh, okay.
You'll see where I'm going with this, right? So if I want, I could write this as x squared minus, right? Minus b over ax. Did I break any laws there?
No.
No, I didn't break any laws there. I'm doing this so I can get it exactly in this form. All right. So stay with me. Isn't it possible? So look at what we have so far, right? If I wanted, and I could take the x and write it over here, since I'm multiplying everything by each other.
Mm-hmm.
So I could write x squared minus x minus b over a. Did I break any laws?
Mm-mm.
Mm-hmm.
No, that's fine. That's valid. And if you look at the left-hand side and the right-hand side, isn't it equivalent?
Mm-hmm.
Right? So, Shweta, if I equate this component here with what's on the right-hand side, wouldn't that be equivalent to Z2 plus Z1?
Yup.
Mhm.
And if I equate the C over A component, which is the quote-unquote real part, you will get that. Now, I want to stress on something, right? Until you remember the difference of two squares, I'm going to blow your mind here too. Until you know about
Yeah.
squares. Until you remember when you was doing SIRS and you had to rationalize. Let me just say you had something like 1 plus root 5. And you would always multiply by the conjugate, like 1
Yeah.
minus root 5.
Yeah.
The reason you're doing that is so that you're going to end up with some, like, okay, remember, the difference of two squares form would look like this. A plus B by A minus B is equal to a squared minus b squared. If I have something in the difference of two squares form, that means I would square both a and b. So in terms of surds, a in this case would be 1, and Shweta, what would be b in this case? In this case, what would b? If you're comparing this on this, what would b be equal to?
Root 5.
Root 5. And any whole point of rationalizing something is to get rid of the surd?
Mm-hmm.
Right.
Yeah.
So if I apply difference of two squares for a surd, look at what's going to happen. It's going to be a squared, which is 1 squared, minus root 5 squared. And if I square it, what's going to happen?
It poofs.
It poofs, right? And it's the same concept for complex numbers. So look at this, right? In surds, in odd maths, we multiplied by the conjugate to get rid of the square root. Because, Shweta, and when you multiply something by its conjugate, isn't it automatically in the difference of two squares form?
Mm-hmm.
Yeah.
Right. And that's just a squared minus b squared. And so that's why you would have multiplied by the conjugate when rationalizing. It's the same concept over here. It's the same concept over here. Let me show you what I mean. If I have 1 plus 2i, right? And I multiply that by 1 minus 2i. To begin with, any complex solution would exist as a conjugate pair. And we know that?
Yeah.
Yeah, we know that, right? So look at what's going to happen here. If I were to find the product of these roots, isn't it any difference how two squares form? And we can see that.
Mm-hmm.
So what is a in this case? A is what in this case?
1,
Where's b in this case?
2i.
2i. So that would be a squared minus b squared, which would be equal to 1 squared minus, open bracket, 2i squared. And Shweta, when we square a complex number, what happens? What we get?
You get I squared, and I squared is minus 1.
Right. And in doing that, we get rid of the complex part. Right? So that'll be 1 minus 2 by 2 is 4. I squared is minus 1. So you're going to put 1 plus 4 is 5. So Shweta, in doing that, don't we get rid of the complex part?
Mm-hmm.
So in any quadratic equation that has conjugate complex roots, A, B, and C always has to be real numbers. And this is why Shweta, remember I said, I strictly said where A, B, and C are real numbers. You notice us saying that?
Mm-hmm.
Because if the roots exist as conjugate pairs, when they multiply by each other, what kind of number are you going to get?
Real?
A real number. So I hope everything making sense. So if something exists if you have complex roots, they're gonna exist as conjugate pairs. And that would tie back to it being, wait, are you hearing me? Or it breaking up?
I think
yeah.
it break up for a second.
Okay.
We had actually a question.
Yeah, so Shweta, I was saying if you have complex roots, right? They're going to exist as conjugate pairs. And if they exist as conjugate pairs, as you could see, when you work it out, the complex roots are going to is essentially going to turn into a real number, right? And this is going to happen every single time. So A, B, and C are always real numbers. There will never be a case where A, B, and C are not real numbers at this level. So all you don't have to worry about CXC trick and all that. All fine, right? But I hope all you understand what I was saying here. So Shweta, in other words, Z2 plus Z1, which is the same thing as Z1 plus Z2, is equal to what? Minus B over here, right?
Mm-hmm.
And Z1 by Z2 is equal to
C on it.
C on A. Lovely. And we would have learned this in AdMaths, right? This is nothing new.
Mm-hmm.
Great. So Shweta, let me show you how easy things gonna be if we utilize that for this question, the same question. Check this. Remember how much working we do, right? Let me show you how we could expedite all our working, like real fast. So, Shweta, they gave us one of the roots to be Z1, and Z1 was 1 plus 5i. Yeah?
Yeah.
Since A, B, and C are real numbers, then we know that the the complex roots have to exist in conjugate pairs. So Z2 would be equal to,
1 minus 5i.
great. And I'm saying that if you want to find the quadratic equation, it's going to be, remember, it's going to be in the form x squared minus x z2 plus z1 plus z1 by z2. Yeah or no?
Say what that?
So, Shweta, if you have the roots, right? If you have the roots, the complex roots,
Uh-huh.
and you just had to plug it into this to get the
Right.
original thing,
Uh-huh. Uh-huh.
I feel like I'm confusing you at some point.
No. No. When you had first said, saying a little too fast on my brain didn't process it, but I know no, no, it is.
Okay, good. Right? Now, I had choose to use x here and not z because I didn't want to make it look very complicated, right? Like I didn't want it to have a bunch of z's. But you understand at this level when you're dealing with complex numbers, right? It wouldn't be in terms of x. You wouldn't see x squared minus x z2 plus z1. You could really see z squared. So Shweta, if I take this, if I take that, right, and I were to write it like this, would I confuse you? Like if I write z squared minus z by z2 plus z1 plus z1 by z2, would I confuse you? I know all you're more familiar with x, right? But Shweta, if I replace the x for a number like z, I mean a letter like z, would I confuse you?
At first it would be pleasant to my eye, but eventually I'll get the hang of it.
Because that's why I use x here. Are you familiar with x? Like are you accustomed to seeing x, right? But the standard and what's the formal thing to do is to use z when dealing with roots here. You wouldn't really see x in complex numbers. So Shweta, and you understand that x is a variable,
Yes.
and we could use any letter to represent the variable,
Yes.
and the standard for complex numbers is z. So instead of writing x squared minus x z2 plus z1 plus z1 z2, I'm going to write z squared minus z z2 plus z1 plus z1 by z2. I'm not doing anything crazy. All I'm doing is replacing the x for z. I'm just using a different letter. Yeah?
Mm-hmm.
You're sure I'm not confusing you?
Yeah.
All right. And I would use this if I want to figure out the quadratic equation. So Shweta, let's apply this theorem and see if we're getting back what we got here, x squared minus 2z plus 26. Let's see. Do you think it's gonna work?
Mm-hmm.
Right? Because Shweta, and all the way in art maths, you'd learn that if you want to find the equation of a root, it's x squared minus the sum of roots plus the product of roots. And you'd learn that.
Yeah.
And that's the same thing over here.
Yeah. Mm-hmm.
Yeah. So let's apply it. So let's find the sum of the roots first, right? So yeah, do you understand that z2 plus z1 is the same thing as z1 plus z2? Yeah or no?
Yeah.
All right. So z1 plus z2, that'll just be equal to 1 plus 5i, right? Plus 1 minus 5i. What's going to happen here, Shweta?
I'm just gonna get one.
I'm just going to get 1, right? The 5i and the minus 5i are going to cancel off.
Hmm.
So Shweta, again, because the roots exist as conjugate pairs, they're just going to cancel. Like the imaginary part just going to cancel off. So
Right.
you
It's
understand
just gonna
why?
get real.
Yeah, you
Yeah.
understand. I hope you understand again why it has to, why A, B, and C has to be real.
Yeah.
Right. Cool. So we found this part over here as 1. And what would z1 by z2 be? That would be 1 plus 5i by 1 minus 5i. And that would be equal to what? 1 by 1.
1.
Or we could just use difference of two squares. That would just be 1 squared, right?
Yeah, I
minus,
understood that.
and 1 squared is, right? 5 squared is 25, and I squared is,
-1.
right. So you're going to end up with 1 minus 25 and minus 1, which is going to work out to be 26.
Yes.
So,
It's so slay.
yeah, very slay. Oh, you know this meme? Ah, Lele. Ah, I don't know what,
Yeah.
Ah, Lele, ah, Lelas.
with the fish, like the puffer fish.
Yeah. Yeah.
Sometimes that's playing in my head. Right, so, Shweta, as you can see, if I want to find the quadratic equation, I know what the sum of the roots are, and I know what the product of the roots are. So I could just use this theorem and get my original quadratic equation. So it'll be z squared minus the sum of the roots. Sum of the roots is 1, so minus 1z, plus the product of the roots. The product of the roots is 26, and that'll be equal to 0. Tell me if you understand that.
Yup.
You sure?
Yeah.
Right? Nice. Nice. All right. So I'm gonna give Ole a question, all right? And I'm gonna give Ole 5 minutes. So Shweta, to find the quadratic equation, which method are you going to employ? Are you going to use the expansion, or are you going to use sum of
No,
products?
someone product.
Nice. Right, nice. So let me give you a question to do.
But like, how is that trick, right? You won't lose marks or anything.
No, that is like an actual method you're supposed to learn. That's
For
a,
real?
yeah, Emma, like when I was doing pure maths in school, I learned that it's in pure maths textbooks. Like if you find a pure, like if like Baha'u'llah like a really good book, right? It's there. It's there as a valid method.
Okay, cool.
Yeah.
Oh, the thing you just showed us?
Yeah. Someone product of roots. I can't believe the teacher didn't show you this. Like she showed you how to manually expand it.
So yes, she showed us how to expand it like that, but I think she showed us how to let me just go in my notes, I'll check.
All right. You'll get full marks. Right. Find
Um
find the quadratic equation whose roots are 3 plus or minus 2i.
well, she just expanded it. Yeah.
Um,
She pretty much okay, she substitutes, so you have to yeah, she expanded it.
eh, here, what go on actually about someone product of roots. This is a known method. So this is a legitimate method. I show it in the syllabus. I show it in the syllabus. I will find it in the syllabus and show you.
Yeah.
The textbook I'm using right now, it literally has that in it. I will show you a picture. Right, but I just want to let you know if you do this, full marks. Because having to multiply 3 terms by 3 terms is not it. That's not it. Nah. We live in modern times, guys. Modern times. All right. So 5 minutes on the clock. Give it 30 minutes. I give it 30 seconds extra. Right? So I'll have to finish this in the allotted time.
Ugh.
So go. Right? So Shweta, remember, it's z squared minus the sum of the roots by z plus the product of roots. Is essentially where I learn in advance. But instead of using x, we're just using z. That's the standard notation.
Okay.
Yeah, like today's session was I had a lot of interruption. Sorry about that.
It's okay,
It
sir.
was fine.
Yeah, because like I was staying like to avoid renting, I stay in my aunt, so
Yeah,
because like rent kind of expensive.
yeah.
Would you say like for like a comfortable, not a bougie, just like a fairly comfortable apartment? How much is it?
Like 2,000 to 3,000
Yeah.
a month.
I
Yeah.
think Ahmed had to pay 1,500 for his own.
Maybe that's way back then.
Can I increase? But anyway, let we not talk, eh? Lock in, guys. I gotta lock in. Wait, wait. Lock in, gang. Lock in, lock in. Come on, man. Lock in. Stop dilly dally. So, Emma, would you have had learned how to find the square root of a complex number?
Um, yeah.
Yeah, okay, cool. I'm gonna give all this some nice homework.
It just go up for like 2 seconds.
What you wanna see? I don't want to like encourage like looking back too much. I want you to figure it out on the fly. So yeah, Emma, we
Okay.
will look back on. Tell me.
Just
Wait,
the part right after B over A, when we find B over A and C over A.
You know how to use that now.
Oh,
All you had to do, Emma, is just add the roots and multiply the roots. And then put
okay.
that's it.
No problem.
um, so we sending it on the chat. Will you look?
Yeah, yeah, send it on in chat. Right? So Emma, it doesn't matter which one you call Z1 and Z2, but Emma, what is Z1?
Z, where? What's Z1?
Yeah. What's the first root?
3 plus 2i.
What's the second root?
3 minus 2i.
Right? Finding product of the roots and the sum of the roots and then use weight other than add mass. Sum and product of roots. And you get answer one time.
No problem.
I don't understand why being bad in add maths would absolutely screw you with pure maths.
Yeah.
Yeah.
Right. All right, Shweta, let me check what you have here. Shweta, you forgot to put equal to 0. It's called a quadratic equation. That reason, eh? Equation. E-
By
It has to equal.
by we'll have first like put this Z squared minus open bracket Z1.
That's supposed to be equal to 0.
Okay.
And
Alright,
then
I'll
then
put
then, then when you have z squared minus 6z plus 13, that's supposed to be equal to 0.
okay, I'll put this in.
Because it's an equation. And internally here equation, that means I had to equal to something.
Yeah.
Yeah.
Yeah. Right? So you know how to check over. If you are correct, when you put z squared minus 6z plus 13 into your calculator, it's supposed to give you the roots 3 plus or minus 2i. So let me do it quickly here. So z1 will be equal to 3 plus 2i. Z2 will be equal to 3 minus 2i, right? And Emma, tell me, if I want to find the quadratic equation, it will be in the form z squared minus, open bracket, what?
The sum of the products is
Nah,
Z.
some of the roots. I just now heard you hear some of the products.
Sorry, yeah, sum of the roots plus the product of the roots. Sum of the roots X plus the product of the roots.
Until they see this like fat dude going around on TikTok like trying to raise up people. All they know what I'm
Trying
talking.
to raise people?
Yeah, yeah. And he'd be like, "What's up, huz?" Or something like that.
No.
I was
I think
I was
so.
sorry. I feel like all the only same kind of brain rot that I'm on TikTok. Maybe,
Basically.
right? Um, so minus the sum of the roots plus the product of the roots, so Z1 by Z2. So Emma, let's speed run this, right? I want to cover finding the roots of a complex number today, right? I want to do that. I give all there some questions of homework. I want to cover roots, right? So Emma, let's find Z1 plus Z2 first. That's very simple. If I do that, the, the imaginary parts will cancel off, right?
Mm-hmm.
And I'll end up with what?
You'll end up with 6.
6. Right. Right, the next one we're going to multiply. So Z1 by Z2, that's going to be equal to 3 plus 2i and 3 minus 2i. Again, this is the difference of two squares. It's not that deep, bro. It's not that deep. It's going to be a squared minus b squared. So that's going to be 3 squared minus 2i squared. You did this sum up?
Yeah.
Like, it really don't make sense to expand it completely when you could just use difference of two squares. Way better than that, you know? 3 squared is 9, all right? And Emma, what is 2 squared?
4. So it'll be 4 by minus 1, and you get 13.
Right. So my answer would be what, Emma?
X squared.
No,
Oh, D squared minus 6C plus 13. Sorry, I have to get to the hang of using Z.
yeah. Right, and that's the answer. And if I wanted to check if my answer was correct, Emma, what would I do?
You'll use the quadratic formula.
Yes. I could just use a calculator. So let me check. So 1x squared minus 6 plus 13. Okay, nice. We are correct, skills. Until let's see now. 3 plus 2i and 3 minus 2i. Yeah?
Mhm.
Nice. Cool. I will give you all questions of homework. Fear not. Let's look at how to find the square root of a complex number now. Square root. It's someone baby cousin teeth fall out and he come running to show me and tell me he gonna be rich. If that was the case, I let somebody punt cuff my mouth now.
I know, right? Like, can we go back to the days when we were young?
Yeah, and so I don't want to say shit, but naive, like, or like just unaware, you know?
Mm-hmm.
Mm-hmm.
Right. All right. So square root of a complex number. Things are gonna get fun, guys. Are you ready?
Yep.
Okay, cool. So Shweta, I'm gonna call upon you for this, right? So Shweta,
Hola.
um, you want me to give you the general procedure or like just do a question? What you want me to do?
You have time for both?
Um, actually, I should just do a question. Let me just do a question.
Okay, yeah.
And I'm calling you because simultaneous equations is involved.
Right.
All right. So example.
Oh, that's when you square root both sides and square it and
Mm-hmm.
solve simultaneously.
Right. So let's look at an example. So we want to find the square root for 3 minus 4i. Okay. So, Shweta, if you find the square root of a real number, wouldn't you get another real number?
Yes.
So if you find the square root of a complex number, what do you think you're gonna get?
A complex number.
Exactly. So let me show you how this is gonna go, right? So we want to find the square root of 3 minus 4i, correct?
Mhm.
Yeah.
Isn't our answer also gonna be a complex number?
Yeah.
Mhm.
So we're gonna say that it's gonna be in the form x plus yi. Notice I'm not using a plus bi because that's the standard form of a complex number. We want to find the square root of a complex number. So you want to use different variables, right, Shweta?
Yes.
As a matter of fact, a plus bi would actually be 3 minus 4i, right? So if you want to find the square root of a complex number in the form a plus bi, um, you just need to note that the final answer would be in the form x plus yi. It's also a complex number, right? Next up. So Shweta, what you're going to do is you're going to square both sides now. You're going to square both sides. Why do you think I square on both sides, Shweta? It kind of
To
interesting.
get rid of the square root.
Yeah, but it kind of interesting. If I want to find the square root, I have to square to find the square root. It's interesting. But we're gonna square both sides for that part, for that same reason, right? To get rid of the square root. If we square both sides, what's gonna happen to the left hand side, Shweta?
The square root go poof.
Yeah, you go poof. Right? So 3 minus 4i. And on the other side, we are not amateurs. We can do this by now. We can do this without expanding it, right? And so it's just gonna be x squared, right? X squared plus 2 what?
XYI.
FYI. Right? Shweta, you understand that? You understand how we get 2xyi?
What's that?
Because watch, if I were to expand that out, right, that would just be x plus yi by x plus yi. Right? And if you were to expand that out, again, I hold you guys a very high standard there. So Shweta, if I were to expand that out, that'll be x by x, and that'll be
Sure.
x by yi. And then it'll be yi by x. Then it's gonna be yi by yi.
Oh, when is y squared with the I squared, it'll be minus y squared.
Yeah, it'll be minus y squared.
Yeah.
Yeah, it'll be minus y squared because I by I is I squared, which is minus 1 minus y
Mhm.
squared. So altogether, that's gonna be x squared, right? X by yi is gonna be x yi. Then we have another x yi over here. That's how we got the 2xyi. And then yi by yi would be minus y. Everybody understand? Let me put
Yeah.
two again. I don't want anybody to get confused. So yi by yi. Are they probably thinking why me instead of yi? That's a good one. That's a
Isn't
good
it supposed to be a plus and then it will turn to the minus after?
Yeah. That was a good one, eh? Why me? Why me? Yeah. I had the minus there because I had jumped to the answer one time, but if we're gonna use these notes to study, I don't want to just jump straight to the answer. That's wrong.
Right.
I just put it full working, right? Put it full working for now.
Wrong.
Right? So 3 minus 4i, right? So straight up, what would xyi plus xyi be?
2xy.
Right. And this is gonna be y squared and then I squared. And recall I squared is equal to negative 1. Right? So 3 minus 4i is equal to x squared. Right? So that's going to be minus y squared.
Yeah.
So Shweta here, you with me so far?
Mm-hmm.
So Shweta, Notice on the left-hand side, we have a real part and an imaginary part. The real part is 3, and the imaginary part is what?
4 minus 4.
Minus 4i, right? Cool. Now, Shweta, that's on the left-hand side. On the right-hand side, can you tell me what are the real parts?
On your right hand side,
Yeah, on your right-hand side. What's looking like the real parts?
x squared and minus y squared.
Right, because those don't have any I in it, right?
Uh-uh.
Nah. So I could group that together and I could write x squared minus y squared. So that would be the real part over there. And I would write back plus 2xyi. Lovely. And so let me color code this thing. I'll color code it. And I'll also do something additionally. Shweta, if I start to lose it, tell me, right? So, Shweta, is it possible for me to write 3 minus 4i as 3? Again, tell me if I'm losing here. Could I write it as 3 plus minus 4i? Is that legal?
Yes.
Yeah.
Yeah, that's legal, right? Because a positive by a negative would just be negative 4i anyways. So that's fine. So Shweta, now we're going to equate the real and the imaginary parts. Equate real and so Shweta, if I equate the real parts first, what would I end up with?
X squared minus y squared is equal to 3.
Right? You're going to end up with x squared minus y squared is equal to 3. Yeah. And if we equate the imaginary parts,
2xy is equal to minus 4.
yep.
Yeah.
But wait, Shweta. I hear what you're saying, right? And I completely understand what you're saying. Actually, I'll just show you in the next line, right? So you're telling me 2xyi is equal to minus 4i?
No, 2xy is equal to minus 4.
Right. I was gonna say you could divide both sides one by I, and it'll just cancel off. That's valid as well. Right?
Forget them, I.
That sounds so corny. Forget those eyes.
Forget them.
That sounds so cringe. Nah, but to be honest, I'd be saying some real cringe things too. So I guess
Exactly.
it's just humor
If
around here. Is it humor around
you,
here?
yeah, if you wouldn't cringe, life would be so boring.
Wait, so you ever say anything controversial on your lives?
Well, like Charlie Cook.
Sure.
The only controversial thing
Yeah.
I've seen in my life right now.
I watched, okay, this sounds kind of creepy, but I think I've seen every angle of this man getting shot.
I'll just see why I can't upload this on YouTube publicly. I'll just see why. Yeah, boy. Next thing Trump called me telling me how maybe I shoot man on. Boy,
Yeah, Charlie Cook was Trump's little boyfriend.
yeah, yeah. I want to say all that. I don't want to say all that. I don't want to be. I want to stay as politically unaligned as possible.
Yeah.
There's a relax. That's fine.
Right. So let me continue. Right. Continue. So, Shweta, you understand everything so far? Yeah.
Mm-hmm.
Cool. This probably bringing back memories when all you had to do ellipses in unit one. Until I remember the form x squared over a, right? Minus
Yeah.
y squared over a is equal to 1.
Yeah.
Eclipse.
Yeah. All right. So, Shweta, we have 2 equations. You need to make a third one. Which equation looking easier to make the third equation from?
No, the first equation.
The first one?
Uh-huh.
I would actually say the second one. Because Shweta, if you have to make either x or y the subject of the formula in equation 1, square roots would be involved. You know why I'm saying that?
Oh, Speed. Okay, yeah.
Because if I want to make x the subject, I can move across minus y squared, but then I would have to find the square root
Oh
of
no. Okay, yeah.
you understand?
Yeah, okay. Yeah. We're using equation two.
Using equation two. Way boy. Emma, you like yawning there, boy. Way.
I'm trying to solve through the screen.
Way boy. Emma is a big whale. Emma Emma is a whale, boy. And you know those whales is like make like one big gulp and I just
Mm-hmm.
water go just flow into their mouths.
Yeah.
Yes.
Yeah.
Inside a whale mouth, so cool, though.
Yeah, like the I forget the name of the structure they call it. But it's like a bunch of
I
like here like teeth.
yes.
Oh yeah, yeah.
If you ever watch Percy Jack, oh no, is it Percy Jackson? No. From Nemo, I think it's Nemo. When okay, sorry guys, I'll just sleepy after I'm mixing up which movie it is.
Sure, we'll find it.
I,
Mhm.
and I'm not sure I know what you're talking about.
I in either Percy Jackson or Nemo, it had a whale and it swallowed one of them, either Dory or in Percy Jackson somebody, and it had showed all the like the hair teeth kind of structure and like how the water was filtering through it and stuff like that.
Wait, I think it wait, I think I know what you're talking about.
Mm-hmm. Okay, then it's probably Nemo.
I had to watch back Nemo. I have to be honest, I had to watch back Nemo.
Okay.
I thought Nemo used to make me feel depressed.
No, like the whole movie just depressing, honestly.
Yeah.
Yeah.
Like it is. So
You know what movie depressing? Um,
my life,
The Good
yeah, Tama, the good.
The Good Dinosaur.
Oh,
Oh,
I didn't watch that. I know it was sad.
my girlfriend told me how it was real sad, so I didn't bother to watch it.
I cry. Well, as a child, right? I watching that and I crying. My throat and thing locking up because I feeling sad. Imagine if I watch it now, I go bust down in tears.
The Good Dinosaur.
Mm-hmm.
When that come out?
Oh, but a few years ago.
Which years ago? Honestly.
That come out in 2015. That's the year I
Oh,
graduate primary
like
school.
10 years ago.
Wait, you graduated primary school?
Well,
Oh yeah.
I went into secondary school in 2015.
Okay.
Yeah. I will watch The Good Dinosaur with my girlfriend. I try to think of like a really, really sad series that I genuinely it's a sad series that I was like.
Sad series, you say.
No, like I mean a sad movie. What's a sad movie I watched? Um I had this one with what's the name? I'll give away the name, like it's real sad. Real sad.
Hmm.
It's like it's like a loop of depression. I will show you.
Oh,
Right? But let me continue, right? So Shweta, we're gonna use equation two to make equation three. We want to make the subject X or Y.
make why subject?
Y.
Hmm.
Oh, I was waiting to say that one. Yeah. So let me make Y the subject. Cool. So to do that, you'd have to divide both sides by
2x.
What?
right. So Y would be equal to minus 4 all over 2x. The 2 could go into minus 4 minus 2 times. So that'll be minus 2 over x. What? Why did I write 3? Make no sense. Right? Oh, I want to come into my one of my like form 4, form 5 class and and scare them, like with the maths, something. I don't know, like get them like an inspirational speech or something.
For us?
Are
Yeah, yeah. And it's like my top students, you know, yeah, yeah.
are they nice or like are they quiet?
No, they're real nice. It's real talk. It's real talk. Like a surprise. Like this is real talk. They're real cool. Yeah. Actually, before I had you all, I had advance. Teach advance like at 30 minutes before like at 30 minutes before teacher's class. Teach
Mm-hmm.
advance. Yeah.
Okay.
I was doing logs with them. I remember that.
Yes.
Yeah.
Yeah. Right? So y is equal to minus 2 of x. So Shweta, what am I gonna do with y is equal to minus 2 of x now?
You're gonna substitute that into equation one.
Right. So substitute.
Oh wait, how your student do from what's her name? Then it start with R?
From convent.
Um
The one I was in
is
advance
oh
with.
no wait no Amy. Is it Amy?
Yeah. She got one in advance.
How's she doing her other
Nice.
subjects?
She got ones on distinctions.
We're not
Wow.
going for
She bad. And she do like advance like what in 3 to 4 months?
what?
Yeah. Privately with me, yeah. Like she did it in school. She real bad.
How come she
Wow.
just decided to like do it 3 to 4 months?
Well, it's the time frame that was allotted, but she loved maths, actually. She real love maths. Like my
Wow.
level
Mm,
like my level, I love maths.
mm,
She like I feel like if Ollie was more crazy about maths, Ollie would be like that. But I feel like it's still have a boundary. Like shit, so I just get the vibe sometimes I like it's like a love-hate relationship. I
Yeah,
think
yeah, yeah.
that's some status you posted that is like
Yeah,
it's like
yeah,
a
I just okay, so like you see how like you teach me and I understanding it, I would be like good with it. But it's only like in class, like in school, when I'm drained and I'm tired and I'm exhausted and miss teaching and I don't know what's going on, that'll stick more because I'm not in the right mind set to learn and she just going if she wants to.
yeah, I could understand how that's feel. Boy, that has been me every day in UES. This man, okay, so they have four topics that they need to finish for the semester in maths.
Mm-hmm.
This man finished Fourier series in 2 days. That was the long thing I showed you, the long thing. And
Yeah.
Mm-hmm.
that's not a short topic, eh? It's not a short topic. It's not. He finished that in 2 days. And like with the tutorial, where he's supposed to do questions, he halfway do one question and does it. It's crazy. Things are real bad. I'll
What?
pray for me. But it's math, so I'll be fine.
Yeah, no, but like, I mean, there's university wide teachers pulling that though.
Boy, I don't know now. Is a new lecturer. That lecturer wasn't he never really teach our course before. It used to be a lady, and she used to take your time. Yeah.
Hmm.
Mine is just lucky. I mean unlucky, I guess. If you see the probability we had to do, boy, oh God. Probably see that like a ball.
Hmm.
Is that the same thing they might do in the actuarial thing?
Yeah. Along the lines of that probability. Wait.
So what they used to clean your iPad screen and always have fingerprints and it look so ugly.
I just use a microfiber cloth. I'm blind now, so I have plenty glasses lying around.
Oh wait, I have my glasses.
You don't have glasses.
Um,
Yeah, I have one.
Since when? Since when you wearing glasses?
I know, it's just my eyes got kind of strained a little bit, so I get plenty headaches, so I just have to wear it sometimes.
Because I never know you to wear. Um,
I'm not wearing it right now because I'm not
shame.
feeling too.
Yeah, you had to send us a picture. I had to see it with the glasses. I never see it with glasses. I feel like you gonna look like a real devout mathematician. Yeah, exactly. All right. So Shweta, let me continue, right? So we're gonna plug y is equal to minus 2x into equation.
Mhm.
So I'm gonna write back x squared. For y, I'm going to write minus 2 over x squared. That's gonna be equal to 3. So minus 2 squared is going to be what?
4.
X squared is going to be x squared. And that's going to be equal to 3, but I'm going to move
Mhm.
across that 3 one time. Tell me who with me
Yeah.
so far.
Mhm.
Okay, cool. So what do you think I should do next, Shweta? Do I like working with fractions?
Now multiply by x squared throughout.
Right, we should multiply by x squared on both sides. If we do that, we're going to end up with x to the power 4, right? Minus 4 minus 3x squared, yeah?
Mhm.
And that's going to be equal to 0.
Yeah.
Now, you're probably holding your head and being like, wow, what the hell to do? Since when?
Nah. I know what to do. Let
This,
our next letter be equals to x squared.
yes, this is, you gotta do this in odd mouse, like this guy,
Logs. We used to do that in logs.
and not just log.
Like,
This is disguised quadratic equations. That's like the topic, disguised. Like, sometimes you don't have like x to the power, you don't have x plus 2x to the power a half plus 3,
Yeah.
for example. But yeah, what you're saying is correct, right? But before I do that, I'm gonna write it as x to the power 4 minus 3x squared minus 4 is equal to 0. All right, and then
Wait, you mean like x squared is equal to 8?
x squared is equal to 8.
Like that?
Yeah, I mean, technically, you could choose any letter you want. Technically, but preferably, um,
Z?
yeah, actually, let me stay away from those because x and y have a purpose in this equation. You know, we just use z when we find the roots for a complex number. So maybe we should stay away from it. Let me use something like c as a safe one. So let c be equal to x squared. If I do that, we're gonna end up with c squared minus 3c minus 4. Everybody with me?
Yeah.
yeah.
To get c squared, that would just be c by c. What number would you have to multiply to get minus 4 and add to give you minus 3? What could multiply to give you minus 4? But when you add it, we give you minus 3. And
Minus 3 minus 1.
nah,
Hmm.
I think you mean to say minus 4 positive 1,
Oh, wait, take it back 3. Oh, yeah.
right? So it has to multiply to give you the last term and add to give you the middle term. So Shweta, if you multiply minus 4 and 1, where's that?
If I multiply minus 4 and 1,
Yeah, minus 4 by 1 is?
minus 4,
If you add minus 4 and 1, what are you going to get?
minus 3.
Right. So I'm going to loop back to something we did earlier today. Look at that again, right? So Shweta, watch this again, right, Shweta? Minus 4, I could write that as minus 4 by 1, right?
Mm-hmm.
So I say in minus 4 and 1 is the roots. If I multiply minus 4 and 1, I get the last term, so product of roots. And if I add minus 4 and 1, I get the middle term. Yeah. So it's going to be c minus 4, c plus 1. Shweta, I feel like I'll lose you somewhere.
No, don't worry. I understand.
You good, right?
Yeah.
Okay, cool. So we're going to have c is equal to 4, and we're going to have c is equal to minus 1. Everybody understand?
Yeah.
Mm-hmm.
Then you're going to recall what c was. So c was x squared. So recall that C was equal to x squared. You can use any letter, C, H, whatever. Once it's not any of the ones already in use. So then we're going to say x squared is equal to 4. If x squared is equal to 4, right? How much answers I have there? I'd find the square root of 4. But anytime you find the square root of a number, how much solutions do you get?
2.
Right? A plus or minus solution, and
Yep.
right? Just keep that in mind. Right? And straighter. Then I have
Mhm.
then I have x squared is equal to minus 1. And if I find the square root of that, x would just be equal to what? What's the square root of negative 1?
I.
I.
Right? Remember that?
Mm-hmm.
Cool. So next up, we're going to plug this into y. Right? I'm going to plug this into y. So we said y was equal to minus 2 over x, right, Trita?
Mm-hmm.
Right? Y was equal to minus 2 over x. So if x is equal to positive 4, then y will be equal to what?
Minus a half.
Plus 2 and 4.
Right? So y will be equal to, yeah, tell me if you understand that.
Yeah.
Right? I'm going to use some different colors.
Yeah.
The pink. I'm going to use this pink.
Pretty pink.
Good. Very girl pop. Yeah. Right. So when x is equal to 4, y will be equal to minus a half. Put that in pink as well. Right, these are a purple now. When x is equal to negative 4, Thomas Ritter, y will be equal to what?
A half.
What was
Ah. Oh.
a half?
Oh. A half.
It's not like he was gonna say, oh, Lily. And
Ah, lily, lily, ah, lily, glass.
that thing is
Ah,
so
lily, lily, ah, lily,
infuriatingly
glass.
addictive.
I love the colors he uses in GoodNotes. It's so nice.
Yeah, no, and again, like inspiration for what colors to go on makeup.
It's like a palette. It's like a pastel hue I'm trying to go for. Yeah.
Hey, so you ever try free notes?
Nah.
Is literally good notes on crack.
Serious?
Yeah.
Okay. Can I do this? Remember, like, the whole reason I get good notes is because, like, had a math feature. Like, I could have convert things
Mm,
to, wait,
okay, okay. I don't know if we could do
nah, like,
that. I didn't test it out that much. But I would say pretty good. Okay, I know for good notes it's hard to pay, but for poor people like me, yeah, I will use free notes.
no, but, like, you could also, you could pay for a one-time subscription. I mean, I was saying one-time subscription. You could pay for a lifetime. I think it's like 24 US or something for one time, and
Yeah,
you pay the rest.
no, we're not gonna pay for that.
If I had a credit card, I'd pay for it fair. Sure,
I don't even have a credit card.
if I ever see you, I'll pay for it fair. Yeah, that contribution.
Oh my God. I don't even have a myself.
Now, but like, I find have this app called Nebo even better. Like, check this. Like, I could write this fancy thing here. So, like, n is equal to 1 to infinity, like, sine n, wait,
Mhm.
right? Check this out. Wait, convert to math. Bam. That's so cool. That's so cool.
Gorgeous.
I could do any
Oh,
color I want. So like I could say like let me just say E is equal to MC delta theta, right? This is so cool. So cool.
How does it know? Oh my God.
This app better than and look how much wait.
Oh,
Yeah. And you have like a unlimited space there. Like you could just keep scribbling on forever. Yeah.
Nemo, you say, right?
Say that again?
The name of the app.
No, I didn't say Nemo. Nebo.
Oh,
Yeah. Nebo. I will send you the link after. Yeah. I gotta pay for it though.
oh.
Crush your dreams fast.
Yeah, you should.
It used to
See,
be
you should mention it from the beginning.
no, but like I find it worth it. Like these apps worth it. Because you pay for it once and you have it for the rest of your life. I find it worth it. Mhm. All right, so guys, the last one when x is equal to I, you're gonna get y is equal to minus 2 all over I.
Mhm.
We're gonna I want to hold on to this, right? So keep this in the back of your mind, minus 2 over I. So if that's the case, I want you guys to remember, enter the start. We said that the solution would be in the form. So remember, and we said that recall, we said that if you want to find the square root of something in the form a plus bi, wouldn't it be in the form x plus yi? We said that at the start. Straight up.
Yeah.
Remember I was saying that?
Yes.
Yeah. Did we find x and y? And we find x and y?
Yes.
So the first solution, right, for the square root. So, right, so the square root of it was, I believe it was 3 minus 4i. It's going to be equal to, it's going to be 4, right? Plus minus a half is just minus a half I. Yeah? Yeah, you're okay with that?
Mm-hmm.
That's the first one. Then the other one is going to be minus 4, right? Plus a half I. So you with me so far?
Yeah.
Okay. And the last one is going to be, but you're gonna notice something interesting, right? Watch out. It's gonna be I plus minus 2 over I by I. Sure, tell me if I confuse you there.
Mm.
But
Yeah, confused man, but why it looking like that?
there goes the right? If I were to simplify this, right? Notice that the I and the I would cancel off, hence,
Yes.
and that would leave me with I plus by minus 2, which is the same thing as minus 2 plus I. Yeah?
Oh. Okay.
More familiar, right?
Yeah.
But let me check something. Let me show you how to check if your answer correct, right? Check this. So, if I'm saying that the square root, I have to put it in complex mode first. You press mode, press menu, press 2, it's in complex mode. So, straighter, if it's correct, right? And if I square my answers, what am I supposed to get? If I
When you square it.
if I square any of my answers, I'm supposed to get what? Okay, straighter, let me get I can try it. If I wanted it to find the square root at 25, and I tell you the answer, how can I check if 5 is the answer?
Press 5 squared.
Say that again?
Press put calculate 5 squared.
Exactly right. And you're
Do the
supposed
reverse.
to
Or
get what?
something.
When you put 5 squared, what are you supposed to get if you're correct?
25.
Right. So if we are correct, remember, straight up, we wanted to find the square root of 3 minus 4i. So in other words, what number do you have to multiply by itself to get 3 minus 4i? Yeah?
Okay.
If we are correct, when I put 4 minus a half I in my calculator and I square it, what am I supposed to get?
3 the square root of 3 minus 4 I.
That's a bit weird.
Um, oh,
Wait, I'm trying to model my calculator. It's a bit weird. 1 second. Square root of. That's 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 interesting. Let's try minus 2 plus I and see what's gonna happen. If I do minus 2 plus I, minus 2 plus I squared is okay, that works.
is there like some values that will work and don't work?
Wait, it's supposed to work. Supposed to get all the answers. That's weird. Let me check back. I don't think we did anything wrong. So we said that the real parts was x squared minus y squared. That'll be equal to 3. 2xy is equal to minus 4. Take minus 4 over 2x. That'll be 4 over x squared. Right? It's about 4 minus 4. Oh, I see why you're wrong. Watch this, guys. When I found the square root of 4,
Oh,
that's such a noob mistake. That's crazy.
Oh no.
Right? Everybody understand where the confusion come in?
yeah.
You see why it's a good thing to check back to see if the answer makes sense?
Mm-hmm.
Yeah. Right? So I'm gonna write x is equal to plus 2 and x is equal to negative 2. Right? So straight away if I'm doing that, gonna get minus 2 over x. It's gonna be minus 2 over 2, which is
You got when x is equal to I is when you made I the subject of the formula.
wait, say that again?
You got x equal to I when you made I the subject of the formula.
No. When we
Wait,
x squared equal to negative 1, right?
yeah.
Remember, we got two values. When we factorized, we got c to be 4 and we got c to be minus 1.
Mm-hmm.
And remember at the start we said that c was x squared. So then I ended up with x squared is equal to 4, right? So my answers would be plus 2 and minus 2 for x.
Yeah.
And I also got x squared to be minus 1. The square root of x is I,
Yeah.
right?
Okay, and
I'll go over it when we finish, right? So Shweta, what's minus 2 over 2?
Minus 2 over minus 1.
What is minus 2 over minus 2?
1.
Right. So it's a new mistake, boy, damn. This is why I just never get 100 in maths, eh? I'll get like 97 or something.
me too.
Stop out. When I feel have a syndrome for that. Because I
I've
have that
I've
syndrome.
never gotten full mark. Wait, I probably did once, but basically I've never gotten full marks in ad maths before or pure.
Okay, Emma, check you. You're looking very slay with the glasses.
Yeah.
Big up. I don't see the picture. It's, it's like you're always so close. It's like it's almost like you're finding the limit as the mark approaches 100. It never does quite approach 100. It never does reach 100. It's like limit as a mark approaches.
So one time I was so proud of myself for pure. I got 46 out of 50 in one of the topics I was really struggling with. It was with ellipses and thing.
Yeah.
And I showed Mr. Rambert. I was like, Mr. Rambert, look how good I do. And he was like, what, the 4 marks just run away? I was like, sir, I've never gotten full marks in pure or advanced before.
I wonder why that's happened to us.
You should overthink.
No, like
What the
I
thing?
no, I feel like the reason why we make that mistake is because we were studying the torque tripleness. I feel like if it was doing it and it was focused, we would not make that mistake because square root of 4, right? Imagine doing big pure maths and forgetting to square root 4.
No, that has happened to me, you know. That has happened to me, you know. When I
In
square it
every
and something, yeah.
So wait,
in every single report I have in privacy, Miss Lachman always says makes simple mistakes.
that is the crux, you know? That's like the Horcrux. I don't follow watch Harry
Harry
Potter.
Potter.
Yeah. Well, wait, like guys, let me put on the solution and verify if it's correct, right? So when x is 2, it's gonna be 2, right? Plus yi, that's gonna be plus minus 1i. So it's gonna be 2 minus I. Shweta, are you confused by that?
Nope.
Okay, so Shweta then, tell me the next answer.
Minus 2 plus I.
I want you to notice something.
Uh,
Is the same.
Yeah, remember I told you, look at that. Let's just remember that.
Yeah.
Yeah, it would be the same. So oftentimes when you're doing this, like one of them must be the same. One of them must be the same. Yeah, one of them
Okay.
must be the same. Right? So let's check if the answer is correct, right? So, Shweta, when I square my answers, what am I supposed to get?
The square root of
No, no,
3.
no, not the square root of 3 minus 4i. Remember, Shweta, the whole point of this was to find the square root of 3 minus 4i. So, in other words, the question come like, okay, the question, it come like it asking us to find the square root of 25, right? If I tell you the square root of 25 is 5, and I want to check if your answer is correct, wouldn't you put 5 squared in the calculator?
Yeah.
yeah.
And what are you looking for, if you're correct?
25.
Right, so Teresa, if I get 2 minus I for the square root, and I square this, what am I looking for? Not the square root of 3 minus 4i. 3 minus 4i.
Oh, okay.
Yeah, because Teresa, again, if I ask you to find the square root of 25, and you get 5, and to check your answer, you would say 5 squared.
Mm-hmm.
Are you looking
Okay.
to, are you going to see if you're getting the square root of 25?
Mm-mm.
No, and you're trying to see if you're getting back 25 itself?
Mm-hmm.
Right. So let me see if it works out. So 2 minus, gotta make sure you calculate it in complex mode. 2 minus I squared. So when I press equal straight, what am I supposed to get?
Wait, complex mode is
Menu,
comp?
menu 2. Press menu on 2. Yeah,
Menu.
it's comp.
Wait, let me check the blue calculator.
When you press it, once the mode is on, you should see a little eye on top.
Mode.
Let me
Oh, okay, okay.
get my calculator.
Yes.
Yeah, so it's actually CMPLX. Press 2.
Mm-hmm.
Press 2 for CMPLX in the
Yeah,
9.
yeah.
Okay, I'll get through.
Yeah.
Right, you're going to put, so the first one we're going to test is 2 minus I. So you're going to put 2 minus, you're going to press ENG to get I.
ENG.
Yeah, it's right next to the open and close bracket, right next to RCL.
Wait,
Uh-huh.
start over. What we have to do?
So, Emma, you want to go on menu, then you want to press 2 to go into complex mode.
Menu is mode on your calculator.
Yeah, complex mode.
Right? Once you're in complex mode, now you can actually work with complex numbers. So you're going to
Oh,
open a bracket, then you're going to put 2 minus, to get I, you're going to press ENG. That's this button over here,
yeah.
right? Then you're going to square it. Now, when I square it, what am I supposed to get, Gills?
3 minus
Minus
y.
y.
Bam. Badness.
Boom, shakalaka. Yes.
Yeah. And if I put If I put minus 2 plus I,
You get the same thing.
Boom, shakala.
bam. So it makes sense,
Yeah.
right? And you're probably wondering, well, what am I gonna do with our minus 2 plus I? Am I gonna write it back twice? The answer is you're just gonna write it once. Just gonna write it once. Because it don't make sense writing back the same thing twice. So you understand what I mean?
Mm-hmm.
Yeah,
Oh, okay.
right? But you still want to have this piece of working somewhere to the side. You still want to have it somewhere to the side, right? Because you don't want to disclose it all together. You want to have it somewhere to the side. But because you got the answer already over here, you're not gonna write it back again. You understand?
Right. Yeah.
Right, so let's find the square root of 3 minus 4i. Let me see if the calculator could actually do it. Right, it says math error. Oof. What if I put it equal with a 3 minus 4i? Nah, can't do it. Calculator is not broken. Right, so do you guys understand how to find? It seems like a lot of working. It seems like a lot of working, but I don't feel
I
like
understand.
it's not that hard, right?
Mm-mm.
Yeah, I feel like it's manageable. So Shweta, you want me to just recap it one more time before I end class?
I think I pretty much understand everything.
Yeah, sure.
Mm-hmm.
So I'm going to do a recap anyways because I'm stubborn and I want to make sure you understand, right? Like, I'll say some soft stuff today, so I just want to make sure, like, I'll be 100% okay with this. Right. So, first things first, right? Shweta, you learned that if you have a quadratic, right, and it's in the form az squared plus bz plus c is equal to 0, once a, b, and c are elements of real numbers, then the roots would exist in what pairs? What pairs? That's what C.
If it exists as a complex number.
Wait, I hear what I'm saying. If you have a quadratic equation
Uh-huh.
form and A, B, and C are elements of real numbers, then the roots would exist as what? The roots would exist as
Mm.
what?
Real numbers.
No, conjugate pairs. You see why a recap is important?
Yes.
Don't worry, Shweta. I'll make sure you understand this, right? So let me go back to the example we did, right? So Shweta, look at this example here. So Shweta, and this is clearly a quadratic equation,
Mm-hmm.
right? A, B, and C are all of them real numbers,
Mm-hmm.
right? When you found the roots, you realize that the only difference between them was what?
The
This thing.
signs.
Right. The only difference is the sign in the middle. So if the only difference is the sign in the middle, then they would say that the roots exist as conjugate pairs,
Conjugate.
right?
Okay, yes.
Roots exist as conjugate pairs. So in other words, straighter, that just means that it would be in form A plus or minus BI. Yeah?
Yeah.
Cool. Nice. If you are given one root, let me just say you're given a root z1 is equal to 5 minus I. Do you know how to find the original quadratic equation from that?
Yeah.
Mm-hmm.
How would you do that?
So you get the conjugate pair, which will be 5 plus I. I want to come up with the equation for it. As you said.
Yeah.
Right. And so then we're going to use the equation for sum and the product of the roots and the so for where it is sum, you have z1 plus z2, and for
Well,
where it is per
what would that be? Tell me one time. What would Z1 plus Z2 be?
10.
Right? I'll show you how fast you do this now. And
And for the product, it would be oh gosh, what's it called again?
so we
Uh,
difference of this
huh?
one.
Yes, difference. It'll just be the differences of two squares.
Right? So that'll be plus 25. Put that in brackets, 25. Then that'll be it's gonna be
Minus
minus
I
I.
squared
So that's gonna be plus 1, right?
plus 1. Yeah.
So how fast we do that? Real
Mhm.
fast. Like, yeah. You do that in like less than a minute, right? So it's very easy. Easy marks, easy 3 marks. Okay. If they ask you to find the roots, the square root of a complex number, again, if you find the square root of a real number, ain't your root gonna be a real number?
Mhm.
Right. So if you find the square root of a complex number, then the answer you're gonna get is gonna be in the form,
Of a complex number.
right? It's gonna be x plus yi. So your first
Mhm.
right? So your first step, you're gonna put you're gonna okay, so if you want to find the square root of 3 minus 4i, gonna apply the square root, then you're gonna
Mhm.
square both sides. Now you are going to put it equal to x plus yi, which is the form of the final answer, right? Like I said,
Mhm.
they're a complex number. So you square both sides to get rid of the square root. You're going to get 3 minus 4i over here. You square this, so you're going to end up with x squared plus 2xyi plus y squared I squared, which is just going to be x squared plus 2xyi minus y squared. Yeah?
Yeah.
Then you equate the real parts and the complex parts.
Mhm.
So the real parts over here was x squared minus y squared on 3, and the imaginary parts was 2xy and minus 4.
Mhm. And then it's simultaneous.
I think you know how to do simultaneous equations. We realized that we had something to the power of 4, and we had something to the power of 2. So what we could have done was we could have done a substitution and said C any letter other than A, B, X, I, or Y would be equal to x squared. Do you understand why we can't use those letters like A, B,
E-
X, Y, I? Because it's already in use, right?
Yes.
Right. So you say C is equal to x squared. And if that's the case, you make your quadratic equation, you solve, right? And if you solve them, you'll get, just remember, when you find the square root, and you're going to get two solutions,
Mhm.
don't get caught lacking, eh? Don't forget that. Anytime
Mhm.
you find the square root, you're going to get two solutions. This is a place where people would make mistakes. So you're okay with everything up to this point? Like, sure, makes sense, 100%.
Yes.
Right, then we consider the different cases for x. So we're gonna look at when x is 2, when x is minus 2, and when x is I. Right? You're gonna recall what the third equation was. The third equation tells us what y is in terms of x. So it's gonna be minus 2 over x. In this case, x is 2, minus 2 over 2 is minus 1. In this case, it's gonna be 1. And well, in this case, minus 2 over I. Right? When you plug it into the form x plus yi, for this one, you're going to get 2 minus I. For this one, you're going to get minus 2 plus I. And for this one, you're going to get minus 2 plus I. So it don't make sense to write minus 2 plus I twice. Write it once. Understand?
Mhm. Yep.
Cool. So that is it for class today. I will send you guys homework.
Yes.
The next class, I want to show you guys how to perform some arithmetic on complex numbers. And I want to do some work on Argand diagrams.
Okay.
Okay.
Right? But before I go, I want to show you how simple like complex numbers is one of the simplest like topics in pure maths. Like it's so easy. I can't stress how easy it is. Like Shweta, watch this, right? With the knowledge you have in odd maths and regular maths, watch how you could handle this, right? So Shweta, remember at the start of class I was showing you some rotation thing. Remember that?
Mhm.
If let me just say I had let me just say, right? I was doing a rotation, right? But instead of going all the way 180 degrees, I stopped somewhere in between, right?
Mm-hmm.
Let me just say I stopped by 3, 2, right? 3, 2. So this complex number is gonna be 3 plus 2i, yeah?
Mm-hmm.
And you can see it forming a right angle,
Yes.
right? So this part over here is 3, and this part over here is 2 ends. Would I be able to find the angle,
Yep.
right? Using trigonometric ratios fast. This could be h. This gonna be what?
That is adjacent.
It's gonna be O. So we have O on A, so we're gonna use tan. We always use tan, by the way. So we're gonna say tan theta is equal to O over A, right? So theta would just be equal to the tan inverse of right, yeah. Give Frank Collins. Probably say take it.
Oh.
Um yeah, so that one be 2 over 3. Don't mind the name. I don't know where I get that from. It's tan inverse of 2 over 3. Tell me fast, where's the tan inverse of 2 over 3?
$53.69.
It's a 33.69 degrees. And then it
I
kind
think I think it has to be in
of radians.
radians.
Yeah, it has to be in radians, right?
I mean,
When you're dealing with
0. Sorry.
when you when the polar form and the trigonometric form, right? You you need to put it in radians. But just for this quick explanation, I think everybody could um could see 33.69 like straight and you could visualize and you could see it for yourself that kind of looking like 33.69.
Yeah.
Yeah, you could kind of see that, right? So that's the main thing I really wanted to prove there,
Mm-hmm.
right? For when we start to look at like harder, when we start to look at it in the polar
That's
the trigonometric form, things are gonna change up, right? Things gonna start to change.
how long is complex inverse though, by the way?
Um, I would say we do our good bits. What takes the longest is when you have to look at the different cases like intersecting loci. When you have to look at the
Oh
different
my
graphs. There's a lot of graphs
God.
you have to remember. It is a lot of graphs. Quite a lot of graphs.
Okay.
Yeah, so like when you're talking about the exponential form, z is equal to rei theta. You have to put theta in radians. And when you're dealing with the other form, which is r cos theta plus I sine theta.
Mm-hmm.
Now, guys, this sounding real complicated, but I promise, like it's not that deep. When we do it, I'll go over the concept and how they come up with it, but it's not that hard, right? When you're doing it in this form, you have to use radians, right? Shweta, I mean Emma, sure you see these two forms before,
Yeah.
right? So this is the exponential form, and this is the trigonometric or polar form.
Yep.
Cool. So that this was just a prelude, right? Like I think everybody understands this. And Shweta, and if I wanted, I could find the hypotenuse
Yes.
using what?
And
You like
anything,
Pythagoras?
both.
Yeah, Pythagoras. Pythagoras. Yes, Shweta, I have a right angle triangle and have two sides. So we would actually call that R. And R stands for the modulus or the length of the hypotenuse. So that would just be equal to the x component squared plus the y component squared. And so that would be equal to 9 plus 4, which is 13. So here what? So Shweta, you know how to find the length of the hypotenuse? This line over here. And you know how to
Mm-hmm.
find the angle between x-axis. So already, I just don't tell you that the exponential form is Z is equal to RE theta I. So you could already write it in that form if you wanted. And you could already write it in the form, in the trigonometric form. So all I already learned to do. Totally, it's really, really simple. The hardest part would be when you had to learn all the different graphs. Let me show you what I mean by that. So when you have to, when you have to,
Is it Pythag some kind of triangle thing you have to do too?
you're talking about Pascal's triangle,
Yeah.
the Morse theorem. Yeah. But this will take the longest when we had to look at the different cases for the loci-Argand diagrams. Like, yeah, I remember all of these cases too. But I'll show you again. I will show you guys how to come up with it, so you wouldn't have to remember it. Yeah. So it was good. It was good having the first class with you guys. I feel like a reunion.
It does. Brings back full memories.
Now I would put on the camera about looking real homeless right now.
Real what?
It's okay.
Homeless.
It is fine.
No, I'll take like a reunion picture.
Alright.
Or you take on next class.
Okay, yeah. We were like fresh up and like I wear a suit and thing.
Okay.
So yeah, guys, I hope you have a blessed night. I hope the first class was good. I'm sorry about the like interruptions and thing.
It's
Okay.
okay. The beat up.
Okay, good. I'll see you guys in the next class. Later, everybody. Bye bye.
Bye. Bye. Bye,
Bye, Shweta.